Suppose if L1 and L2 are the two lines which are parallel to each other, then the perpendicular distance is the shortest distance. We know the vector equation of a line which passes through a point and parallel to a given vector is vector r is equal to vector a plus lambda into vector b. What is the formula? The shortest distance between the lines is given by d2 is equal to b1 cross b2 dot a2 minus a1 by length of b1 cross b2. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhashtam PU College, the Temple of Excellence. In my previous class, we have discussed regarding the derivation of equation of line which passes through a given point and parallel to the given vector, and the equation of a line passing through two given points, both in vector and Cartesian form, and the problems based on that. Now in this session, I am going to discuss regarding the shortest distance between two lines. Now let us find out what is the meaning of the shortest distance and when to find the shortest distance between the two lines. Now the shortest distance between the two lines, if two lines in space intersect at a point, suppose if two lines intersect at a point in space, then the shortest distance between them is always 0. Suppose if two lines in the space intersect, if the two lines in the space intersect at a point, then the shortest distance between them is 0. Suppose if two lines in space are parallel, if the two lines in the space are parallel, suppose if L1 and L2, if L1 and L2 are the two lines which are parallel to each other, then the shortest distance between them will be the perpendicular distance from one line to the other line. Suppose if L1 and L2 are the two lines which are parallel to each other, then the perpendicular distance is the shortest distance. So the shortest distance between them will be the perpendicular distance between them. Suppose if these are the two lines L1 and L2, then the perpendicular distance will give the shortest distance between the two lines. So the perpendicular distance, the perpendicular drawn from one point on one line onto the other line will give the shortest distance between the two lines. Now let us come to this. Suppose if these are the two lines, so these two lines are neither intersect nor parallel. So then the shortest distance will be the perpendicular distance between these two lines. Now let us consider in a space, there are lines which are neither intersecting nor parallel. In space, there are some lines which neither intersect nor parallel, and such pair of lines are non-coplanar, and they are called as skew lines. The lines which neither parallel nor intersecting are called as skew lines. The lines which never intersect nor parallel to each other, such lines are non-coplanar and they are called as skew lines. Now, these two lines are the skew lines. So, these are the two skew lines. Now, for skew lines, the line of the shortest distance will be the perpendicular distance from the line. So, the shortest distance between the skew lines is given by the perpendicular distance. For skew lines, the line of the shortest distance will be the perpendicular to both the lines. Now, let us come to the derivation. To derive the distance between the two lines, two skew lines. Two skew lines means the lines which are neither intersecting nor parallel to each other are called as the skew lines. Now, let us consider two lines. Now, to find the shortest distance between two lines, let us consider two skew lines. L1 and L2 are the two skew lines whose vector equations. So, we know the vector equation of a line which passes through a point and parallel to a given vector is vector r is equal to vector a plus lambda into vector b. Now, let us consider two lines L1 and L2. Let L1 and L2 are the two skew lines whose vector equations are r is equal to a1 plus lambda into b1 for line 1, and the vector equation of the line 2 L2 is given by r is equal to a2 plus mu into b2. So, let us consider two lines, two skew lines L1 and L2. The vector equation of the lines L1 is vector r is equal to a1 plus lambda into b1, and the vector equation of the line L2 is given by vector r is equal to a2 plus mu into b2. Okay. Let us take a point A. Let us take a point S on the line L1 with the position vector as vector A. The position vector of the point S is vector A. And let us consider one more point T on the line L2 whose position vector is vector at. Okay, now let us consider a point S on L1 with a position vector a1, and another point T on the line L2 with the position vector a2. Vector a1 and a2 are the position vector of the point S and T on the line L1 and L2. Okay, so that is, take a point S on L1 with the position vector a1 and L2 with the position vector a2. Then the magnitude of the shortest distance vector will be equal to the projection of ST along the direction of the line. So the projection of ST, the projection of this line ST will give the shortest distance. So that is, the magnitude of the shortest distance will be equal to the projection of ST along the direction of the line of the shortest distance. So suppose if PQ is the shortest distance between the vectors L1 and L2. Now this is the shortest distance. If PQ is the shortest distance between the lines L1 and L2, that is, if PQ is the shortest distance between the lines L1 and L2, then perpendicular to both B1 and B2, we will have an unit vector. Therefore, the unit vector n cap is equal to B1 cross B2 divided by length of B1 and B2. So, if PQ is the shortest distance between the lines L1 and L2, then it's being perpendicular to both the vectors B1 and B2, and the unit vector along PQ, the n cap, the unit vector n cap along PQ is given by vector B1 cross B2 divided by its own length of B1 and B2. Now, since PQ is equal to D into n cap is a unit vector where D is nothing but the magnitude of the shortest distance. The magnitude of the shortest distance is D. So, therefore, PQ is equal to D into n cap, where D is the magnitude of the shortest distance between the vectors. So, suppose if theta is the angle between the vector ST and PQ, then we know PQ is equal to ST into cos theta, or cos theta is equal to, since what is the value of cos theta? Cos theta is equal to A dot B divided by length of A into length of B. Therefore, cos theta is equal to PQ dot ST divided by length of PQ into ST. Okay, since we know the cos theta is equal to A dot B divided by length of A into length of B, here the angle between the two lines PQ and ST is given by cos theta is equal to PQ dot ST divided by length of PQ into ST. Now, just substitute the value, since PQ is equal to D into n cap and ST from the diagram. What is ST? ST, vector S to T is given by, that is nothing but vector A2 minus A1 vector. ST is nothing but second vector minus first vector is OT minus O is the position vector, that is equal to A2 minus A1. So, since PQ is equal to D into n cap, vector PQ is equal to D into n cap, and ST, vector ST is equal to A2 minus A1 vector. Substituting these values and simplifying, we will get the equation for the shortest distance between the two lines. So, hope you followed this. Listen. So, if D is the magnitude of the shortest distance between the vectors and theta is the angle between the vectors ST and PQ, then we have PQ is equal to ST into cos theta, but cos theta is equal to A dot B divided by length of A into length of B. So, the cos theta is given by PQ dot ST divided by length of PQ and ST mod. Since we know what is P to Q, PQ is nothing but D into n cap, and whereas ST is equal to the distance S to T. So, these are the lines, this is S and T, this is L1 and L2. So, that is nothing but A2 minus A1. The vector A2 minus A1 will give the distance A2 minus A1. Now, substituting these values in this given equation, this equation becomes, this is equal to mod of D into n cap dot ST is nothing but A2 minus A1 vector, vector A2 minus A1 vector divided by PQ. PQ is nothing but magnitude of PQ. Magnitude of this is n cap, unit vector is 1. So, this reduces to D, and into ST. ST is nothing but the same magnitude of ST. Okay. So, D into n cap divided by A2 minus A1 divided by D into ST. Since from previous equation we know n cap unit vector is B1 cross B2 divided by length of b1 into b2. So substitute here, this reduces to, so this gets cancelled, unit vector is 1, that is a2 minus a1 into this b1 cross b2 vector divided by length of b1 into b2 along with this st. So on simplification, so this reduces to n cap, you know n cap is equal to b1 cross b2 divided by length of b1 and b2 into a2 minus a1 divided by s into t. Hence the required shortest distance between them is given by the shortest distance, hence the shortest distance, required shortest distance d is equal to pq, that is equal to st into cos theta. Now what is cos theta? This is cos theta. Cos theta is equal to this much. Therefore, the shortest distance d is equal to, this two gets cancelled. What we will get? Mod of a2 minus a1 vector dot b1 cross b2 divided by length of b1 cross b2 vector. Length of b1 cross b2 vector. This is the shortest distance. So hence the shortest distance between the lines is given by d is equal to b1 cross b2 divided by into dot a2 vector minus a1 vector divided by length of b1 cross b2 under mod. So this is the shortest distance between the two lines. So the shortest distance between the two lines is given by b1 cross b2 dot a2 minus a1 divided by length of vector b1 cross b2. That's all. That is the shortest distance. Okay, hope you followed this. That's it. Now listen to me, I will explain once again. So since from this we know cos theta from this is nothing but cos theta is equal to pq dot st divided by length of pq into st. Since pq is equal to d into n cap and st is equal to a2 minus a1, substituting these values in this equation, then the given equation becomes cos theta is equal to pq d into n cap dot a2 minus a1 divided by d into st. So this can also be written as a2 minus a1. Since n cap is nothing but the unit vector n cap is equal to b1 cross b2 divided by length of b1 cross b2. So this n cap is equal to b1 cross b2 divided by length of b1 cross b2 into st. Therefore, the shortest distance between the two lines is given by d is equal to p to q. pq is the shortest distance. This is the shortest distance. So the shortest distance pq is equal to d, that is nothing but st into cos theta. Now therefore d is equal to st into, substitute the value of cos theta. So that is a2 minus a1 dot b1 cross b2 divided by length of b1 and b2. So therefore the shortest distance between the two lines is given by d is equal to b1 cross b2 divided by length of b1 cross b2 dot a2 minus a1, or the shortest distance d is equal to b1 cross b2 dot a2 minus a1 vector divided by length of b1 cross b2 vectors. So this is the formula to find the shortest distance between the two lines. Okay. Now let us take problems based on this. Now let us come to the problem. Find the shortest distance between the lines. That's all. Whose vector equations are vector r is equal to ai I cap plus j cap plus lambda into 2i cap minus j cap plus k cap, and vector r is equal to 2i cap plus j cap minus k cap plus mu into 3i cap minus 5j cap plus 2k cap. So the two equations L1 and L2 are given. So what is given? Given equation vector r is equal to I cap plus j cap plus lambda into 2i cap minus j cap plus k cap. The other equation is vector r is equal to 2i plus j minus k cap plus mu into 3 times I cap minus 5j cap plus 2k cap. Now comparing with, if we compare this with, this is of the form vector r is equal to a1 plus lambda into vector b1. So therefore vector a1 is equal to I plus j, and b1 vector b1 is equal to 2i minus j plus vector k cap. Similarly, if we compare, this is vector r is equal to a2 plus lambda into vector b2. So therefore vector a2 is equal to 2i plus j minus k cap, and vector b2 is equal to, this is b2, 3i minus 5j cap plus 2k cap. So these are the values of vector a1, b1 and vector a2 and b2 from these two lines. Now what is the formula for the shortest distance? The shortest distance between the two lines is given by d is equal to, therefore the shortest distance between the lines, between the two lines is d is equal to b1 cross b2 dot vector a2 minus a1 divided by length of b1 cross b2 vector. This is the formula for the shortest distance between the two lines. Now simplify this. b1 cross b2, vector b1 cross b2 is given by determinant I, j and k. The coefficients of b1, 2 minus 1 1, 2 minus 1 1, and b2 3 minus 5 and 2. Simplify x plus minus and plus, expand with respect to first row. So minus 2, minus into minus plus 5, minus j into this column and row is deleted, 2 2s are 4, minus 3 1s are 3, plus k cap into this is gone, 2 5s are 10, minus into minus plus 3 1s are 3. So this is equal to 3i cap minus j cap, minus 10 plus 7 plus 3 is minus 7k cap. Now the magnitude of this, length of b1 cross b2 is equal to square root of 3 square is 9 plus 1 square is 1 plus 7 square is 49. So 49 plus 1 is 50 plus 9 is 59, root 59. Now similarly find out now vector a2 minus a1. What is a2 here? a2 is equal to 2i plus j cap minus k cap, 2i plus j cap minus k cap, 2i plus j cap minus k cap minus a2 vector. a2 is I plus j. If you subtract, you will get minus I minus j cap. So this is equal to 2i minus I is 1i plus 0j minus k cap. Now find out the dot product. Now b1 cross b2 dot vector a2 minus a1. So what is b1 cross b2? That is 3i cap minus j cap minus 7k cap dot a2 minus a1 is I cap plus 0j cap minus k cap. Simplify this. This is 3 into 1 plus minus 1 into 0 plus minus 7 into minus 1. So this is equal to 3 plus 0 plus 7, that is equal to 10. So therefore the shortest distance d is equal to mod of b1 cross b2 dot a2 minus a1 is 10 divided by length of b1 cross b2 is square root of 59. So therefore the distance d is equal to 10 by root 59 is the shortest distance between the two lines. Hope you followed this. That's all. So d is equal to b1 cross b2 dot a2 minus a1 divided by length of b1 cross b1 will gives the shortest distance between the two lines. Okay, that's it. Hope you followed. Okay, let us come to the next problem. Now find the shortest distance between the lines. R is equal to I plus 2j plus k cap plus lambda into I minus j cap plus k cap and 2i minus j cap minus k cap plus mu into 2i plus j plus 2k. Same, this is same as that of the previous problem. Now what is given? So comparing with, this is vector R is equal to a1 plus lambda into b1 and this is vector R is equal to a2 vector plus lambda into vector b2. Now therefore vector a1 is equal to I plus vector I plus 2j plus k vector and vector b1 is equal to I minus j plus vector k cap. Now similarly for the second line, vector a2 is equal to 2i minus j minus k cap and vector b2 is equal to 2i plus j plus 2k cap. Now what is the formula? The shortest distance, the distance is given by distance between the two lines L1 and L2 is D is equal to B1 cross B2 dot vector A2 minus A1 divided by length of B1 cross B2 vector whose magnitude. So now find out A2 minus A1 first. Vector A2 minus A1 will give this minus this vector 2i minus j minus k minus multiply by negative sign I minus 2j minus k. What is this equal to? This is equal to 2i minus I is I cap minus j minus 2j is minus 3j cap minus k is minus 2k cap. Okay, this is A2 minus A1. So hope you followed this. Just comparing with the standard equation of the line, find out the value of vector A1 and vector A2, vector B1 and B2. Find out A2 minus A1 now and find out B1 cross B2. Now let's go to the next page. B1 cross B2 now. Vector B1 cross B2 is given by determinant I, j and k. The coefficients of B1 are, what is B1? 1 minus 1, 1, 1 minus 1, 1 and 2, 1, 2, 2, 1, 2. Simplify this, expand with respect to first row. I into minus 1 minus 2, minus 1 into 2 is minus 2, minus 1 minus j into, this is gone, 1 2s are 2 minus 2 plus k into, this is gone, 1 1s are 1 plus 2 1s are 2. So this is minus 3i minus 0j plus 3k cap. Now magnitude of this, length of B1 cross B2 is equal to square root of minus 3 square is 9 plus 0 plus 9. This is equal to 18. That is nothing but 3 root 2. Okay, now find out this. Now vector B1 cross B2 dot vector A2 minus A1. So that is B1 cross B2. B1 cross B2 is minus 3i minus 0j plus 3k dot A2 minus A1. What is A2 minus A1? I minus 3j minus 2k. I minus 3j minus 2k. Simplify this. That's equal to minus 3 into 1 plus 0 into minus 3 plus 3 into minus 2. Minus 3 plus 0 minus 6, this is equal to minus 9. So therefore the shortest distance D is equal to D. What is the formula for D? D is equal to B1 cross B2 dot A2 minus A1. So B1 cross B2 dot A2 minus A1 is minus 9 divided by length of this is 3 root 2. Simplify, 3 3s gets cancelled, minus 3 by root 2. So therefore the shortest distance is equal to 3 by root 2. Just remove the mod. So 3 by root 2 is the shortest distance between the two lines. That's it. Okay. Hence the shortest distance for this given line is 3 by root 2 units. That's it. Okay. Now let us come to the next problem, similar type problem. Find the shortest distance between the line whose vector equations are given. So again the same type problem, comparing with vector r is equal to a1 plus lambda into b1. Okay, therefore vector a1 is equal to I plus 2j plus 3k and vector b1 is equal to I minus 3j plus 2k. Similarly for the second vector, this is vector a2 plus mu into vector b2. So here vector a2 is equal to 4i plus 5j plus 6k cap and vector b2 is equal to 2i cap plus 3j cap plus k cap. Now what is the formula? The shortest distance between the lines is given by d2 is equal to b1 cross b2 dot a2 minus a1 by length of b1 cross b2. Now find out first a2 minus a1 vector. What is a2 minus a1 vector? a2 is 4i plus 5j plus 6k minus a1 vector is minus I minus 2j minus 3k. So this is equal to 4i minus I is 3i, 5j minus 2j is plus 3j, 6 minus 3 is plus 3k. Okay. Now find out b1 cross b2, the cross product of b1 and b2 vector. Now b1 cross b2 vector is equal to determinant I, j and k. The coefficients of I, j, k in the vector b1 is 1, minus 3 and 2. 1, minus 3 and 2. For the second vector, the coefficients of 2, 3 and 1. 2, 3 and 1. Simplify this, expand plus, minus and plus. So this is I into minus 3, minus 6, minus j into, delete this 1, minus 4, plus k cap into, this is gone, 1 3s are 3, plus 2 3s are 6. I into minus 9, minus j into minus 3, plus k cap into 9. So this can be written as minus 9i plus 3j plus 9k cap. So now, therefore, length of b1 cross b2 is equal to, the magnitude of this vector is square root of 9 square is 81, 3 square is 9, again 9 square is 81. So this is equal to root of 81 plus 9 is 90, 90 plus 81 is 171. So now find out b1 cross b2 dot vector a2 minus a1 vector. So that is minus 9i plus 3j plus 9k dot a2 minus a1 vector, 3i plus 3j plus 3k, 3i plus 3j plus 3k cap. This is a2 vector, a1 minus a2 dot product, that is minus 9 into 3 plus 3 into 3 plus 9 into 3. So this is 9 3s are 27 plus 3 3s are 9 plus 9 3s are 27. These two gets cancelled. This is equal. So therefore the shortest distance d is equal to, what is the formula? b1 cross b2, b1 cross b2 dot vector a2 minus a1 divided by its own length, b1 cross b2 vector. So this is equal to 9 divided by root of 171. So therefore the distance d is equal to 9 divided by root 171 units. So this is the shortest distance. Hope you followed this. That's it. This is how we are going to find the shortest distance between the two lines whenever they are in the vector equations. Hope you followed this. So the shortest distance is given by d is equal to b1 cross b2 dot a2 minus a1 divided by length of b1 cross b2. So this is 9 divided by root of 171, that is nothing but d is equal to 9 by root of 171. So this is very important, that is b1 cross b2 dot a2 minus, this is a2 minus a1, that is b1 cross b2 dot, this is a2 minus vector a1. So that's equal to, this is equal to 9 divided by root of 171. So that's equal to 9 by root of 171 will give the distance between the two pairs. So this is how we are going to find the shortest distance between the two lines whenever they are in the vector form. Okay, let us come to the next problem. Now find the shortest distance between the lines. So the Cartesian form. So whenever the equations of the lines are in the Cartesian form, now how to find the shortest distance between these two lines? Now let us convert this Cartesian form into the vector form. So this can be written as, now the first equation is vector r is equal to a1 plus lambda into b1. Convert to this form, vector r is equal to a plus lambda into vector b. So this can be written as, this is minus I cap minus j cap minus k cap plus lambda into, this is vector b, that is 7I cap minus 6j cap plus k cap. This is vector a plus lambda into vector b1. This is minus I minus j minus k cap plus lambda into 7I minus 6j plus k cap. Similarly for the second vector, vector r is equal to, this is 3I cap minus plus 5j cap plus 7k cap plus mu into I cap minus 2j cap plus k cap. That's it. Now the Cartesian form is reduces to the vector form. Same procedure as that of the previous problem. So here vector a1 is equal to minus I minus j minus k, and the vector a2 is equal to 3i plus 5j plus 7k cap. Similarly, vector b1 is equal to 7i minus 6j cap plus k cap, and vector b2 is equal to I cap minus 2j cap plus k cap. Find out the vector a2 minus a1. Vector a2 minus a1 will give this minus this. 3i plus I is 4i, minus into minus plus, this is 5 plus 1 is 6j, minus into minus plus, this is 8k cap. So 4i cap plus 6j cap plus 8k cap will give the value of a2 minus a1. Then find out b1 cross b2 and the length of b1 cross b2 and substitute, you will get the answer. That's it. Now come to the cross product. Now b1 cross b2, vector b1 cross b2 is equal to determinant I, j and k cap. b1 7 minus 6 1, 7 minus 6 1, 1 minus 2 1. Simplify this, plus minus and plus. I into 6 ones are 6, minus into minus plus 2, minus 7 ones are 7 minus 1, plus k cap into 7 twos are 14 minus 14 plus 1 into 6 is 6, minus into minus plus. This is I cap minus 4 minus j into 6 plus k cap into, this is minus 14 plus 6 is minus 8. This can be written as minus 4 I cap minus 6 j cap minus 8 k cap. So length of b1 cross b2 is equal to root of 4 4s are 16 plus 6 6 are 36 plus 8 8s are 64. So this is equal to root of 64 plus 16, 64 70 80, 80 plus 36, 80 plus 36 is how much? 116, 116. Now b1 cross b2 is equal to root of 4 square is 16, 6 square is 36 plus 8 square is 64. So 16 plus 36 plus 64 is equal to root of 116. So this can also be written as, this is nothing but 4 into 29, square root of 4 is 2 root 29. So b1 cross b2 is equal to 2 root 29. Okay, now find out now b1 cross b2 dot vector a2 minus vector a1, dot product of these two. That is, what is b1 cross b2? Minus 4i minus 6j minus 4i minus 6j cap minus 8k cap dot, what is a2 minus a1? 4i cap plus 6j cap plus 8k cap, 4i cap plus 6j cap plus 8k cap. Now this is equal to, so this is minus 4 into 4 plus minus 6 into 6 plus minus 8 into 8. This is equal to 4 4s are 16, 6 6 are 36, 8 8s are 64. Add this. Same, minus 16 minus 36 minus 64 is again equal to 116, minus 116. Now therefore the distance D is equal to, distance D is equal to, what is this? Magnitude of b1 cross b2 dot vector a2 minus a1 divided by length of b1 cross b2 vector. The distance D is equal to modulus of b1 cross b2 dot a2 minus a1 is minus 116 divided by length of this is 2 root 29. So you can take mod out, minus becomes plus, 116 by 2 into root of 29. If it is possible to divide, divide it. 2 5s are 10, again 2 8s are by root 15. So therefore the distance D is equal to 58 divided by root of 29 units. So this is the shortest distance between the two lines. So these are few problems to find the shortest distance between the two lines whenever the lines are in vector form as well as in the Cartesian form. So whenever the equations of the lines are in the Cartesian form, convert it into a vector form and use the formula distance d is equal to b1 cross b2 dot a2 minus a1 divided by length of b1 cross b2 under mod. That's it. So these are few problems based on this shortest distance between the two lines. Now let us discuss different concept in the next class. So that is regarding this session. Let us discuss the next concept in the next class. Thank you very much.